Hi everyone, welcome to another episode of Mr. Carlson's Lab. Today on the floor are two extremely large audio power monoblock amplifiers. Each one of these amplifiers weighs just under 200 pounds. So they are going to remain on the floor. I'll do the videoing on the floor today. I don't need just under 400 pounds extra weight on this bench right now. So I would say, not really comfortably, but I would say to move these things somewhat uncomfortably. 4 people, 1 at each rack handle, I would say. The majority of the weight is up front, right behind the meters. When these things were moved, 2 of us did it, and not good. So should be at least 3, I would say, strong people, or 4. Preferably to move an amplifier like this. So if you're thinking of getting an amp like this, plan on some weight. Anyways, each one of these amplifiers has 20 6550s in each one, so a total of 40 6550C vacuum tubes. Can you imagine replacing 40 of them, and all of them are matched as well? That's not all. There's other tubes in there as well. So each unit has 34 tubes in total. All right. The idle current for these things in operate, so sitting there waiting for you to turn your volume control up on your preamp, is 800 watts each. So of course you have stereo, you have 2 of them. That's 1600 watts of idle current, and it goes up from there when you turn the volume up. So they are very large. 600 watt audio output each. That's 600 watts under optimum conditions. 550 average for each unit. So very, very powerful amplifiers. And very impressive specs as well, down to 2 hertz. There is a lot of iron in these amplifiers. It's the reason they weigh, just under 200 pounds. Anyways, the problem with these amplifiers is each a meter problem. So both have 1 meter problem. So we need to find out what's going on with the meter in each one of these units. So what I'll do is I'll relocate the camera down there, and we'll take a look. I'll remove the lid. I'll show you around inside. We'll take a look around the amplifier, take a look at the backside and all the jacks they've got. This will work down to 1 ohm. You can drive speakers at 1 ohm with these things. They're very versatile and really a neat design. Each output tube has its own bias control. So that's the way things should be built. If you're going to design a vacuum tube amplifier that's push-pull, make sure each one of the audio output tubes has its own bias, not one bias for 2 tubes. So that's good design. Right there, that tells me that Audio Research knows what they're doing. So very, very good design there. What we're going to do as well is I will download the schematic or find a schematic on these things somewhere, and we'll go over the design. We'll take a look and see how well Audio Research did putting this thing together. How does that sound? So lots of stuff to do today, lots of fun. Let's get started. Here's a closer look at these Audio Research Reference 600 mono blocks. So as you can see, compared to the intro shot, they really are quite a bit bigger than they look there. I guess the wide angle lens makes them look, pretty small, but they are really quite big. 1200 watts of audio right here. And hey, when you're not listening to audio, you can attach your arc welding leads to the backside through a 6013 in the stinger and join some steel. So they really are that big. Anyways, the audio transformer, or just the transformers alone inside these things, are the size of the transformers that you would find in some of the smaller broadcast transmitters. That's really how much iron there is in these things. So I can see them being able to keep up to the frequency ratings, no problems. Really, really heavy. I don't know if I can even demonstrate how heavy these things are. I don't know if that accurately... I don't know if that demonstrates how crazy heavy these things are. Anyways, yes, heavy. So I did find my notes on these, and one of them has either a bad meter light circuit or just burnt out meter bulbs. I really don't know. If they are burnt out meter bulbs, that'll be a nice, easy repair, I think, unless I have to disassemble the meters to get to the bulbs. I haven't had the tops off these things. I haven't plugged them in. I haven't done anything, so we're going to discover all of this together. So again, my notes say one has no meter lights, and the other one has a mechanical 0 issue. Now I did fool with the mechanical 0, so right in the middle of each meter is a mechanical 0, and the meter on the very far end over there will not mechanically 0. which usually indicates that there's an issue inside the meter. So we're going to have to remove that meter right out of the amplifier and see what's going on. Maybe the needle's counterbalance has fallen off on the bottom and gone into the meter or something like that. But anyways, we'll discover that together. Now my notes could be interchangeable. I don't know, maybe they have more problems than what's actually in my notes. We'll find that out as we go. I can see this one here is missing a few screws. It's actually, the heads have been broken off, so their threading is still in there, so somebody has snapped the screws off. Now these things here obviously need to be dedusted, because there's big fans in the bottom of them, and there's lots of tubes in here. And of course, if the tubes have ever been checked or replaced, you have to remove them all. So somebody's obviously done that in the past. But anyways, we'll take a closer look at the face on these things, and then I'll turn it around. I'll show you what's on the backside, show you the audio jacks. They did a really nice job there. These things are beautifully put together, just again, incredibly heavy. But what do you do? If you want that kind of frequency rating with that kind of power, you need the iron, and that's just the way it goes. And these things have no shortage of iron, let me tell you that. So we'll turn around, take a look at the backside, and then we'll remove the top, look inside, we'll take a look at the design. I'm really excited to look at the schematic. I want to see the design for these things. So I've yet to download one and look it up and go over it, but it looks like it's put together like a brick, what. And here's the backside of the amplifier. So pardon the dust again, I haven't dedusted anything. I usually do that right in the end. So we can see we have the unbalanced common right here, and from here to here we have 1 ohm. So for those of you that like to drive dead shorts, those are your jacks right there. And we have 2 ohms from these two, and 4 ohms, and then we have 4, 8, and 16 ohms. So it's quite accommodating to the load that you'd like to drive. We have a balanced input here, so XLR type input, standard for some of the larger amplifiers. Line cord, very big line cord here. And the fuse and rack handles on the backside, and that's pretty much it. So I'll get the screws out of the top side here, and let's take a look inside, see what's inside this thing. All right, this is the maximum vacuum tube viewing camera angle. So as you can see on this side, we have 8 6550s here in the audio chain. We have another 8 6550s here in the audio chain. If you look carefully underneath, you'll see some orange rings. So those orange rings on those tubes, those are the driver tubes for these 6550s right here. So they're double triodes, I would imagine 12AX7s or something like that. Again, I have to look at the schematic to find that out. And I'll dig one of those up later on. So there's 4 on the bottom, and it's the exact same thing on this side. So they're basically just exact same sides. So we have 4 of the same thing on the bottom here, probably 12AX7s, and the same thing here. So lots and lots of tubes here. In the back side, we have another 4 6550s here. This is the power supply. So these are most likely going to be pass elements of some sort. So probably has screen grid regulation. That would be the logical thing to do. And these are most likely regulating the screen grids for all of these vacuum tubes right here. We have another 2 regulator tubes that are going to be doing something in here. I don't know what they're doing. They look like 12B4s. I don't know what they are. The internal structure looks like that at any rate. What does it say on it? Am I missing the number here? 7233. All right, so there's more of those. There's a lot more tubes in the backside here you just can't see. Again, this is the optimum vacuum tube viewing angle. As you can see, the very, very large transformers in the front. Extremely big transformers. Again, you find these things in some of the smaller broadcast transmitters. 4 fans in it, so 2 fans on that side and 2 fans on this side. Electrolytics in the center here, so filtering in the middle. I'll see if I can move the camera around just a little bit here. Maybe we can get a better view of that. If you look straight down on it, pardon the vibration and the moving here. I'm just trying to get the view of everything in here all at once. So you can see all the electrolytics in the center here. Lots and lots of filter capacitors. 470 microfarad at 450 volts. These ones are all rated at. And I can't see the ratings on these ones because they're covered up in the center. All right, backside vacuum tube view right there. Right in the front is where we need to focus. So what I'm going to do is move this up. And I'll zoom into that meter. And hopefully you can see what's going on there. So you can see it, the bulb holders in the bottom. So I'll just get a pointer here. So you can see the bulb There's bulb holders in the bottom, so these look like they just would snap out. So chances are the bulbs can be replaced. And these hold in the meters here. So I'm imagining this screw, there's another one on the bottom, and then it looks like the screw that holds the circuit board here would be the other screw that holds on the other portion of the meter, and then I have to undo these two wires here and here, and I should be able to get that out. So the bulbs look very easily replaceable, and in fact they look like they would very easily come out. Let's see if I can pop one of them out. This has all been safely discharged, by the way. I've created that that device that safely discharges capacitors. So I've used that on this to make sure that there are no charged up capacitors. And yes, they do come out. And that's it right there. So if the bulbs are bad on the other amplifier, that is going to be a nice, easy fix. Or even if the bulbs are bad on this one, again, I don't know what's going on. So I'll just leave that out and we'll put that back in. I'll put that back in once the meter is out because it's easier to pop that back in. So this entire board's going to have to come out because there's a nut on the top and there is a nut on the bottom as well. So I can just loosen all of these up at first. So what I mean a nut on the top and a nut on the bottom is there's a nut on the top side of the board, and then there's a nut on the meter side of the board as well. So there's lots of things to be undone here. Yeah, no washer there at all. A big head in the shot there. Isn't that nice? Now we got the LEDs on the front side of the board here that poke through the front of the unit. And there are the nuts that we need to get to the actual meter. So to get the meter out. So let's have fun removing some of these. Definitely not easy to get this thing apart, right? But not bad either. All right. Well, the bulb is part of the thing. I'll push this back in and pull the bulb out. There we go. That bulb out of there. And there we go. There it is. It won't focus on it because I got the focus fixed, but we'll take a closer look at this. That's where the bulbs sit in there. And we're doing pretty good. So I'll get this up on the bench and let's take a look at this thing, see if we can get this thing to mechanically zero. Oh yeah, I see screws. So here, let me see if I can touch the focus up here. There we go. So I see screws. That's a good sign. So we can get this thing apart and look inside and see what's going on with that meter movement. Here's the meter out of the unit. On the bench, this is soft, a piece of foam, so I don't want to be scratching anything. And that's what it looks like from the back side. So two little light pipes basically to make the meter illuminate nicely. The screws here. So I'll show you what I mean by mechanical alignment. And this is very important so that the meter reads correctly. So I'll just zoom on into this. Okay, so there's the meter face, and this needs to sit right on that line. So you get a screwdriver that fits that adjustment screw very nice, and then you move this around. You see I can pull it back. And that's as close as I can get. And then you pass it and it goes back again. So you can usually go in a full circle. Sometimes these meters, you can run the setting right up into the top. And it has a kind of a fine and a coarse adjustment. But this one here, that's it. You can see it won't sit at the 0. So if you're setting your bias and you want to set your bias to the center line up here, you know, you're going to be off by that much or more, right? So, you know, the way that this is sitting right now, the way that there's pressure on this holding this back, it might actually decalibrate the scale as you get higher up. It's, you know, hard to say really. So this should actually be centered. So I should be able to move it above it and below it. All right, and then I should be able to put that right on that line. So there's something wrong with the movement inside here. So what I need to do is get this meter apart. And it looks like it's just these screws right here. So let's see, I'll just let that focus on there. And in fact, I think what I'll do is I will just fix the focus, and then that way it's not going to be running all over the place. All right, so there we go. So now we're fixed. Move this here. Just leave that in there. Come out with a meter. That one wasn't very tight. It was actually very loose. So if I grab those surface mount tweezers again, you can never have too many of these things around. You find these things useful for so many different things. Let's put them up here for now. Get them out of the way. All right, let's see if this thing comes apart. Now I will need to turn that back to continuous again. And I'll just get that out of the way. And look at that. Comes apart just like so. So there it is. So now I need to figure out why this isn't zeroing. All right, I just took a quick look under the microscope, and it looks like you can see that this is bent. Everything is there. The weight is there. So I'll put the little zoom in on the little counterbalance there. I don't know if you can see that. You can see the little counterbalance is there. I'll turn on this light. See that little wound spring down in there? Little spring right there is wound on that shaft. So it's there. It hasn't fallen off. So if you look at this, it looks like it's crooked. So you see that? I don't know if you can see that from that angle. You see how this looks like it's crooked? This is shifted this way. It's actually bent. So I don't know if they bent that at the factory, and I'll just get rid of this light for a moment. I don't know if they've bent that from the factory. You can see how it's not aligned up. So this is actually bent this way. So if I bend it straight up and down where it should be, it looks like we should probably be able to zero this. So I need to get a pair of pliers in here and then just push on the bottom one and kind of push this over, this front one over. And then I should have all of, that much more adjustment. So you can see when you move this, right? I'll move this. See how we can set the 0 up, right? So it's already so far this way, right? It's already so far that way, but if I bend this back, we'll have that extra bit of movement. So I think that should be able to squeak us in. So right there, is almost straight up and down. And you can see we really need to be right about there to be zeroed, right? So that might give us just that little bit of movement. So the counterbalance hasn't moved, which is a nice thing. I don't know if I can get this any closer. See a little spring that they've put on the other side there. So that's very finely tuned. If that is pushed up or down on the needle, what'll end up happening is that'll decalibrate this. So this is very, very sensitive, by the way, too. Just tapping it, you can move this. I'll just very lightly blow on the meter face. You can see how sensitive that is. So if you come across and you bump that needle or touch it like that right at the top, there's a good chance that you can destroy this meter. So you got to be super, super careful when making any adjustments on something like this. So what I'm going to do is go get a pair of pliers and then kind of pinch that and align the front with the back. I don't know if you can see it. Yeah, there you can really see how misaligned it is. You can see how at the bottom half, you can see how this is over, right? So this is kind of bent this way, and that's more straight up and down there. So if I move this portion back over this way, I think I might get enough just to zero that meter up. All right, let's see if we can straighten this together with just a pair of pliers. So what I need to do is put pressure on the bottom and on the top here. So you'll see, you might be able to see, you can see how misaligned the bottom one is at this angle very well. So you can see the bottom portion here, how misaligned it is from the top. So I might be able to just move this over. You can see that, how I'm flexing them. Very close now. I would say that is looking pretty close. I'm just trying to see on the camera angle here how close we actually are. I think I might be able to get just a touch closer. So as you can see, I'm pushing on the bottom one and pushing the other way with the pliers on an angle. See that? How I can flex the top one over just a bit. That's what I'm doing. All right, so let's see that. That looks like that is pretty straight, doesn't it? Okay, so what we're going to do is put this right in the middle. Put it just right in the center. Okay, and then what we need to do now is take this one here and put it right in the center as well. So I'll zoom in on this for a moment. You see that there? So I need to put that little adjustment right in the middle. Okay, so what I'll do is I'll just grab this from the back side. I can turn it from the back side, put that right in the middle. Just like that, okay? And then what I'm going to do is carefully put the meter face back on. So that should be right in the center of that right now, I'm hoping. So I'll just hold this for a moment. Okay, and we'll see if that gives us any more room here. Okay, so we'll back this out a little bit so you can see what I'm doing. Hopefully this is going to work. Let's see if it does. Aha, look at that. We got it right on this, right on the line. We can actually bypass it. Look at, we can go beyond it now. And that's what we want. We want to be able to sweep each side of that. So there it is. I can get that right on the zero line right there. So zoom in on that. Probably get even closer being zoomed in. So I need to be like straight in the center screen. See, we can actually bypass it now. So I'll stick the screwdriver back in the mechanical adjustment. Either side, no problems. That's what we need. So unless somebody's had this meter apart, maybe this meter's been like that since it came from the factory. I can't see that. You know, on a device like this, you know, it's worth as much money as this thing. So, you know, and of course, you know, screws being, you know, on the top side of the unit being stripped out on some of them. Maybe somebody's been in these and they've messed with it. I can't see that. So there you go. It looks like the meter now is done. Let's see where it sits. Yeah, see, just off to the side. So it's moved just a little bit. Of course, now that I've moved the meter face and I've moved the meter around, things have moved a little bit. But yeah, not bad. So, you know, that gives us our range of adjustment, right? That's what we need. Oh, one thing I should add, always when you have a meter apart, shine the light on it. You always want to clean these things up before you put them back together, because if you put this whole thing back together, you'll see dust and debris on the back side. This was in here. I haven't touched the glass at all. So it's just, this really looks like it could be a replacement meter, or somebody has been in here before, because usually the inside of the meters don't get that, you know, dirty, let's say. It looks like some sort of a greasy film on the back side of that glass. Before I go about reinstalling this meter back into the amplifier, I want to verify its operation. After all, we were bending around a piece of metal in the bottom portion of it, and it had some sort of a weird, I don't know, oily glaze on the back side of the glass is, I guess, the best way I could explain that. So maybe this has been a part and maybe somebody else has been fooling with this thing. I really don't know. So I don't want to put this whole thing all back together and find out that the meter's a dud or something like that, right? So in order to test this, I compared this meter to the meter in the other amplifier. So I removed the lid on the other amplifier and I disconnected that little socket, you know, that little plug on the printed circuit board there, which effectively opens the meter from the circuitry in the other amplifier. So at that point, I can tie into that meter and I can compare both of these back and forth. At that point, I came back over to this meter, and with my source, I started out at 1 millivolt, and I slowly turned the voltage up until I got to 25 millivolts, and that drives the needle to center scale. Now, since we have even numbering here, and you can see the spacing is relatively even, if 25 millivolts drives this to center scale, what should drive this to full scale? Well, 50 millivolts, right? So I turned up my source to 50 millivolts, and sure enough, it comes right up to full scale. Now, whenever you're testing a meter like this, keep in mind, you know, you're not looking for that needle to sit exactly right in the center. It can be a needle's width either side, and that's just standard for the accuracy of all of these meters. So don't get too hung up on trying to keep that needle, you know, directly in the center there. In a lot of cases, it just doesn't work out like that. Remember, we're taking, you know, electricity and turning it into actual movement here on the scale. So if you're a needle's width either side, absolutely okay. Don't get too worried about that, all right? And I'm about that with this meter right here. So what I'll do is I'll apply 25 millivolts, and that should drive this up to center scale. So here we go. I'll close my alligator clips. And there we go. We're about center scale, or close enough too. Now, even just tweaking this zero adjustment here, so the mechanical zero, will move that back or forth just a little bit as well. So another thing to keep in mind there. So I might be a little bit on the high side of the mechanical zero there, which might also be bringing this over about that needle's width, right? So not a big deal. So now, this is being fed with the Datron here over here. So I'll just move this over here. Pardon the camera movement again. So you can see right there, I'm at 0.025 of a volt. All right. Now what I'm going to do, to be careful, and this should always be done before any adjustments are made, because if anything goes wrong, all right, if anything goes wrong here at all, just say I accidentally made that 25 millivolts into 25 volts, I would absolutely destroy that meter in a second, all right? So everything is unhooked, so I want to make all my adjustments over here first, make sure everything looks accurate, and then I will reconnect those alligator clips. So now in order to drive this to full scale, we want to go to 50 millivolts, okay? So we'll go to 50. All right, so now we're at 50 millivolts. So now I feel comfortable that I can reconnect those alligator clips, because I didn't turn that into 500 volts or something like that by accident. Because yes, it will supply 500 volts. Okay, so here we go. I'll reconnect the alligator clips right here. And look at that. No problems whatsoever. Now this tracks identically to the other meter. So no problems whatsoever. So those are, I guess you could say, the official numbers to test these meters. 25 millivolts, you know, mid-scale, and 50 millivolts right at the top end. All right, let's put power to this thing and see what happens. So we'll click this on to standby. And some relays clicked, and I'm within the green zone here, which is a good thing. That's the line voltage. Now the line voltage here is right at 120. So it's right 120.0, maybe 119. So of course, with this thing loading it down in standby, it would make sense. So that's probably 120 in the middle. So 125, 120, and say 115. So that's what I would think at any rate. Makes sense. I mean that this is very accurate as well. So the needle on this one here, it looks like it's above the mark, but it isn't. It's actually right on. It's because the camera is in the center. If I slide the camera right in front of the meter, you can see that it's right on the mark. Ignore the shadow. So there you go. Right. So unless you look at it straight on, they look like they're just a little bit off. And this one here, if we were to look at this one straight on, that's where it's sitting. So there we go. right into the optimum area for us to get going here. So I'm leaving it on standby for just a moment, just to let the tubes warm up, to let the filaments come up to brightness and make sure the cathodes are in emission. So I'll click on auto operate and see what happens now. I have no idea. Let's find out. So the standby is flashing. It might be a safety feature to make you wait just in case you turn this thing on right away and then you want to, apply all the voltage. So let's wait for a moment and see what happens. Either that or it's a protection. We'll find out here. If it's in protection, then we'll have some more troubleshooting to do and find out why it's in protection, but let's see what happens here. So the standard, cathode warm-up time, is between 10 and 15 seconds. So I would imagine this would probably make you wait for some variation of that. Now, there we go, went into operate. And I'm still within the green zone, so I'm doing good. No problems here. Let's see what it looks like straight on. So, yep. Bottom portion of it, but hey, it's still there. All right, so let's see if the meter illumination works. It does. So the lamps work on this. You see that? Look nice. You can vary the brightness. That's kind of nice. All right, and the fans are on right now. I don't know if you can hear this. Turn that right up to the max. So they do get a bit noisy when they're up to the maximum, but they're pushing a bit of air there. I imagine if you were listening to this very loud or stressing it out, that would be a good place to have the fan speed. All right, let's see how the bias is doing. So this biases all of the tubes. So we want to test V1 to V8. So we'll go to V1 to V8 and we're in V1. So it's within the green area, so we're doing good. So that's this adjustment here. So let's go to V2. Not bad, still within the green zone, could be adjusted. All right, and 3 is a little bit high as well. 4, right? So the optimum thing to do is to have this on for about a half an hour and let everything stabilize before you go about adjusting something like this. That one's spot on, isn't it? And the last one, which is V8 right here, is spot on as well. So now if we want to test the second bank of tubes, so that's the first 8 tubes, we go over to this side and move this up. So we're at V9 now. And then 10, 11. Looks like they're all doing okay so far. Put my hand under here. They're all really close, not too bad. So just a few minor adjustments, just a touch of some of the controls would probably bring that back. Let's see how sensitive the controls actually are. Let's find one that's kind of out. That one's pretty off. So we're at V12 here, which would be this one right here. All right, so I'll stick an insulated screwdriver in there. And you just touch them. There you go, just that simple. It's biased up. So anyways, not a problem. It seems to be working okay and the meter lights work. So there it is. I'm sure if I fed audio to this thing and put it into a dummy load, I'd probably take the breaker out. So anyways, back into standby here. Let's see how it shuts down. So it just shuts down and standby goes back to standby. And then on the top here, got my hand above the tubes. Wow, does that ever emit a lot of heat? You could easily heat a room with this. No problems. Have 2 of them in a room and it would probably get rather uncomfortable pretty quick. So definitely good area heaters. So I don't know if you want to see the tubes glowing here. I don't even know if we can. They glow a little bit. The heaters are kind of, I guess you could say, hidden. They're almost like dark heaters like they are in the 6146s. There we go, you can see all the filaments glowing in all of the tubes. in there. So anyways, there it is. It's working, no problems. And the other amplifier is going to be pretty much the same thing. I imagine it's just going to be, the dial lights or the meter lights. So the meter lights are working in this one, and that was the complaint with the other one. So let's shut this thing completely down and see how it shuts down. All right, here we go. Off. And lots of relays clicking in there, and then there we go. And it settles back off. So that's it. So the other one is just going to be meter lights. That's it. So you saw in this one here how to replace the meter lights, so not a real big deal. Just replacing light bulbs is kind of boring, right? So I'll just get that done and away they go. Let's take a look at their design. And already I can tell you it's looking really nice. So we have a whole bunch of 6550s here in the output stages. And you can see we have lots of resistors on the plates. We have resistors on the grids, both on the control grid and the screen grid. So these are just stoppers. And the reason that they have these here is we don't want the tubes to see each other. This is a high-powered audio amplifier, not a high-powered oscillator. So if the tubes see each other, they will self-oscillate and cause all sorts of issues. So basically, these are just stoppers. So we have two stoppers on each plate. We have a stopper in the control grid, standard 1K. And then on the screen grid, we have 100 ohm resistors here all the way along. On the cathode of each tube, we have some resistors down here. And what we're doing is we're just reading the current at this point here. So this is where we're getting our current readings when we're doing the bias adjustments across those resistors right there. Transformer is a very special device. Lots of windings inside this transformer. So I imagine that would have been a very costly thing to put together right there. So pretty standard stuff. Looking very straightforward. Nice design already. It almost looks like the just the way that they're putting some of the stuff together here, it almost looks like maybe the engineers at Audio Research, maybe ham radio operators. There's a lot of things that kind of lead into that. So once you see some of the designs over and over again from ham radio operators, they all kind of blend. So here we have a whole bunch of 12AX7s. Those are the tubes just below the 6550s here, and these are the drivers right here. And these would be all the bias adjustments here on the cathodes of each one of these tubes. So we're adjusting the large power tubes by adjusting the cathodes of each one of these 12AX7s right here. So basically one triode for each tube. It's a nice big resistor network in here. Nice design. We have a 6922 here driving these, and then driving this. We have another 6922. On the bottom here we have an op amp with the outputs attached to the cathodes of each of those tubes. Pretty nice design. This looks like feedback. It is. It says feedback. So feedback right here and feedback right here. So very nice design. They've done a really good job. Like, I mean, it's just from a quick glance, it's looking very nice. Look at this power supply. Wow. Look at all the rectification going on here. Lots of diodes, lots of filter caps everywhere, lots of tube filaments. It's everywhere. So those 6550s, those four in the back are pass elements. So they're using them as the regulators. So these are the pass elements that are controlling the 320 volt line. It looks like 320 from here. So what are they doing here? So the control grid is being pulled high by this, and it's being pulled down by this 6922. So that's what they're doing. They're using that to control this. And this is obviously going to be controlled by this op amp right here. So we should have from the output line, which was this here, we should have a line running down to the op amp, which we do through these two resistors here, and then this should run off to a negative supply, which it's doing. So there we go. So this is controlling this. This tube is controlling these four very large ones here. And we have a bunch of Zeners on the line as well, and a relay that's controlling them, it looks like. And this would obviously probably be for standby or something. So there we go. So U14 pin 3 it says there. We'll have to look at that in a moment. And it looks like they're doing the same thing down here for the negative supply. So we've got 7233 right here, right? And each one of them is a single triode, right? So they have, this is a single triode inside here. So one cathode and 2 grids and 2 plates, right? Yep, they're all the same here. So yeah, just a single tryout inside the 7233. It looks much like a 12B4, but it is a 6-volt version, and they have a little bit different specs, but they look identical to a 12B4, and they kind of do the same thing as well, but they are a different tube. So same kind of idea as they're doing up here. We have a resistor pulling this, going to the positive side, and then we're going to have this, you know, basically pulling down at this point. So we have that control here. And we have an op amp doing that. So now what they're doing with this is they're being tricky. They're using this, they're regulating the positive side of the negative supply. And then of course the negative portion of the supply just runs out. We get our negative voltage over there. So hey, that works just fine. No problems whatsoever doing that. Bunch of Zeners here in series. All of our dial lights here. So the meter lamps, as you can see, are all in series. There's the control right there, the AC line meter. They're reading that on the low portion here of the transformer. They're not actually reading the line voltage. They're on a tap on the secondary side. And let's see here. Here's a lot of things. Here's something that a lot of people don't know, I should say. So you can see right here we have 4 filaments, right? And that's the filaments of these vacuum tubes right here. And you can see it's an isolated winding, and we have 2 100 ohm resistors here, and then we've tapped that. We're running this over to the high voltage line. So they're putting high voltage onto the filaments. Why are they doing that? So that you don't get breakdown between the filament and the cathode. So what they're doing is they're elevating the filaments. So by elevating the filaments, you don't risk that issue. If there's too much of a difference in potential between the filament and the cathode of the tube, you get breakdown because they're in very close tolerance. You know, you have a filament and a sleeve inside each one of these tubes, right? So they're elevating the entire filament string here, which is a very smart thing to do. And again, that tells me that the engineers here know what they're doing. That's a very smart thing to be doing. So yeah, just standard stuff. Looks like standard 78, 79 series regulators here. And yeah, very straightforward. And we have more. It's the amplifier that doesn't end. So we have an NE614AN as part of the analog meter drive circuit. What is this? This is an FMIF IC right here. So it's an FM intermediate frequency IC. I'm telling you, the designers at this place are probably ham radio operators. So anyways, they're using an FMIF IC in the analog meter drive circuit. So, you know, a bunch of TL072s, right? We need this to drive the meter forward, but not backwards. So you can see we have some rectification here, and we have a time constant 10 meg and 0.33 here. So we get that kind of swing forward and slow return, swing forward and slower return on the meter. So you can see what they're doing here, you know, very straightforward. And we have a whole bunch of 555 timers doing all sorts of different things, operating standby and doing all that. So we have a low line mute, and we have this here, standby. It says here, standby, yellow LED bypass. So 30-second standby. So they have a 30-second ramp up. So that's that waiting that we had going on there. So when we click it from, you know, standby to operate, that's the wait, about 30 seconds. So it seemed a little shorter than that, but, you know, possibly 30 seconds. So probably controlled by this capacitor right here. So I didn't look to see if this is a tantalum. So whenever you're doing any type of timing circuitry, you should always use something like a tantalum when you're dealing with a value this large. If you put an electrolytic in there, right, they're all over the map with heat. So this is just a flasher circuit. Very simple stuff. So, you know, 555 timers and NE614s, you know, hey, it's simple, right? You know, TL072 op amps, this is good stuff, right? Very simple. Okay, you know, there's a lot of, I guess you could say, this circuit really shines. Let's look at it that way, all right? This stuff is all available. There's nothing proprietary here. You know, you can almost, you know, go down to your local grocery store and buy this stuff. That's how common these parts are. You know, so this is great designing. You don't have an IC in here that's got, you know, let's say, you know, hidden or encrypted information inside of it, and, you know, a security bit that's been, you know, nothing like that, all right? This is just all standard off-the-shelf parts. you know, this thing will be serviceable forever, really. You know, like, I mean, any 614s you can probably find in most junk AM, FM radio receivers, you know, as a spare part. So it's just looking good. You know, like, I mean, the design's just looking good. Everything they've done in here is, you know, I guess you could say spot on. Like, I mean, the engineers and the designers really knew what they were doing here. So good on you. Good on you, Audio Research. The guys that designed this get actually 2 thumbs up. It's a really good design. And believe me, if it didn't deserve 2 thumbs up, I would not give it. So good job, guys. Thanks for stopping by the lab today. Hope you enjoyed this video involving these 2 very large audio power amplifiers. If you are enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the very near future. If you're interested in this type of thing, definitely subscribe and tap the bell symbol. There'll be a lot of repairs, restorations, teardown videos, circuitry design, all of that great stuff on this channel. And it's not only involving older equipment, it's newer equipment as well. So there'll be a lot of solid state and vacuum tube equipment repair and restorations here. Lots of great stuff planned for the near future. Definitely be a part of it. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and a very effective way, you're definitely going to want to check out my ongoing electronics course on Patreon. I also share many of my personal electronic inventions and designs there. So many of the little inventions and designs that you've seen on this channel in the past, all the plans to build them, everything is up there. Definitely check it out. It's a great place to be, and there's a lot of great people there. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.